Good afternoon, everyone. Today we shall be looking at the subject chemistry, and the topic before us is atoms. What are atoms? Atoms are the smallest indivisible particle of an element, and they are made up from matter. And when we say matter, matter is anything you can feel, anything that has weight, mass, and occupies space. So anything you can feel at all, air, ruler, anything around you is a matter. So the smallest part of that matter is what we call atom. An atom can be defined as the smallest indivisible particle, that is the smallest part of an element that cannot be further divided. So we have what we call atoms, molecules, and ions. These are matter. These are the smallest part of matter. So constituents of an atom, constituent. When we say constituents of an atom, we say what are atoms made of? Atoms basically are made up of three subparticles. We call it proton, electrons, and neutron. These are three subparticles of an atom, meaning atom can be classified into three particles: the protons, electrons, and an atom has a structure. The structure of an atom, atomic structure, looks like this. Atomic structure. We have the central nucleus, which consists of the proton and the neutron, then surrounded by electrons in an orbital form. So this is the basic structure of an atom. An atom has the central nucleus. This is the nucleus. This is the proton. And this is the neutron. And these are the electrons. The protons are positively charged with certain amount of mass, while the electrons are negatively charged. The proton actually complements the electron. What do I mean by that? The proton has the proton has the same amount as the electron. The number of proton is usually equal to the number of, but the reverse is the charges. While proton is positively charged, the electron is negatively charged. So if we have 6 amounts of proton in an element, automatically we have 6 amounts of electron in an element. But on the other hand, the neutron has no charge. The neutron has no charge and is centrally located in the nucleus. All right. The electrons are very light and negatively charged. They revolve around the nucleus in an orbital manner in order to neutralize the positive charge in the nucleus. Yes, like I said, the number of electrons always equal to the number of the proton. So, but the electron is negatively charged so as to neutralize the positive charge of the electron, of the proton number. Yes. The atom is electrically neutral because the number of electrons revolving around the nucleus is equal to the number of protons. Yeah, we said that. The proton has a charge of +1. Sorry for the typographical error. The mass of 1, which is the proton, with a charge of +1. The neutron, on the other, has a mass of 1, but no charge. The electron, on the other hand, has a small mass, that is 1/1840, with a negatively charged. So while we see the three subparticles of matter, that is atom, molecules, and ion. A molecule, on the other hand, is a group of atoms. A molecule is the smallest particle of a substance that can exist alone. and still retain its characteristics. So when we say a molecule is a combination, it's a multiple number of atoms. For instance, we can have a molecule of chlorine, which is one chlorine plus another chlorine. This one makes a molecule. So this is one atom. So to make a molecule is defined as the multiple of atoms. So we rather call this one molecule instead of calling it two atoms of chlorine. So the number of atoms present in a molecule is what we call the atomicity. Atomicity simply means the number of atoms present in a molecule. So in this case now, we have chlorine. Two atoms of chlorine here make two atoms of chlorine in this molecule gives it 2 as the atomicity, meaning what? We have 2 atoms of chlorine here. So we can have other example like oxygen. Oxygen, this is a molecule of oxygen. So the atomicity of oxygen here is 2. We can have another one like O3, which is ozone, made up of 3 atoms. 3 atoms of oxygen, 2 atoms of oxygen. Then we have all other like P4. This is phosphorus. This one gives you 4 atoms. 4 atoms. So the number of atoms present in a molecule is what we call atomicity. Atomicity. The atomicity of an element is the number of atoms in one molecule of the element. We have monoatomic. So when we have only one, for instance, only one atom, for instance, sodium. This is one atom of sodium. This is monoatomic. Monoatomic, meaning only one atom. Another example is calcium. Another example is fluorine. No, this is one atom. Another example is potassium. So these are monoatomic, meaning only one atom. Monoatomic. But when we have 2 atoms, just like here, these are diatomic. Diatomic, meaning only 2 atoms are present in one molecule of the substance. So we also have what we call triatomic, meaning 3 atoms are present. For those elements that contain 1, 2, 3 or more are called Most gaseous elements like oxygen and chlorine are diatomic, while others like phosphorus and sulfur exist as polyatomic molecules, meaning they are more than 2. So, for instance, phosphorus is an example of polyatomic. We have sulfur too. It's another example. So, when these atoms are more than 3, they are called polyatomic. So, atomicity simply means the number of atoms present in the molecule of a substance. All right, let's move on. So, like we said, we have hydrogen, which is H2. It has 2 atoms. So, this is an example of diatomic. Oxygen, O2, diatomic. Nitrogen, O2, NO2, N2, which is also diatomic. Can we move on, please? So, we have explained this. These are monoatomic. This is ozone, O3, and phosphorus, P4. These are polyatomic. Now, ions. They said one of the subparticles we're going to talk about after atom are ions. What do we mean by ions? Ions are charged atoms. When we say charge, for instance, sodium. When sodium undergo a reaction, it becomes from sodium atom to become sodium ion. Chlorine too may undergo a reaction to give you what we call chloride ion. So we can have several ions like that because they are called charged. They are called ion because they are charged. This has no charge, while this one is charged. So when we now have 2 different types of charges, 2 different types of ion, we can have positive ion, we have negative ion. Positive ions are called cations because they are attracted towards the cathode, while negative ions are called anions because they are attracted towards the anode. Of course, we have other group of atoms. Sorry, before we move on, we have other group of atoms which we call radicals. Radicals are group of atoms. They are not just single atom, but group of atoms carrying a charge. An example is SO2, SO4 2 minus, NO3 minus, CO3 2 minus. These are radicals. Anyway, they are not the only negative. We have other radicals that are positively charged, for instance, ammonia. So these are radicals because they are group of atoms. You can see sulfur is there, oxygen is there. Unlike this one that have only one atom, sodium chloride, these are just single element. That's why we call them ion. But radicals are group of atoms. These are radicals. They are group of atoms behaving like a single element with a charge, carrying a charge. So this charge -2 belongs to this sulfur and oxygen. -1 belongs to this N and O, that is nitrogen and oxygen. Then we have this other one, ammonia. This is a group of atoms carrying this charge, that is nitrogen and hydrogen. Now, an acid radical is thus a small group of atoms carrying a negative charge that keeps its identity. The example of acid radicals, just like we said, is SO4. This is SO4 2 minus, like you can see here, SO4 2 minus, NO3, and so on. Generally, ions are grouped as cations and anions. Like we said, cations are positively charged. Every one here that has a positive charge, for instance, potassium, calcium, magnesium, and so on and so forth. These are called cations because they are positively charged, attracted towards the cathode. And the cathode is negatively charged. While anions are what? Negatively charged. Example is chloride, fluoride, ion. Then we have bromide. Yes, oxygen. These are negatively charged, attracted towards what? The anode. So they are called anions. All right. So we had, like we said, we have given you some of the examples. Now let's look at atoms and mass number. What do you mean by atom? Atomic number and mass number. Atomic number can simply be defined as the number of protons in an element. The number of protons in an element makes what we call the atomic number. Atomic number is the number of protons in an element. So for instance, if we have, and it's denoted by a symbol Z, this is the symbol for atomic number. Now, for instance, if we have oxygen, oxygen has the number of protons to be 8. 8 number of proton in there. Then we have another, sodium has 11 proton. Then another one is sulfur. Sulfur has 16. So the number of proton in an element makes up what we call the atomic number. What about the atomic mass? The atomic mass simply means the sum total atomic mass. On the other hand, atomic mass is denoted by symbol A. This is the symbol for atomic mass. Atomic mass is the sum of the proton number plus the neutron number of an element. By the time you sum the proton number and the neutron number, you have what's called the atomic mass. Let's look at the example below. We have sulfur. Okay, let's see. Oxygen. We said oxygen has proton number. Okay, let's make it above. Now we can see. This is the proton number. This is the neutron number. So for oxygen with this, it has 8 as the neutron number. Sodium has 12 as the neutron number. Sulfur has 16 as the neutron number. So for atomic mass now, is the sum total. We said atomic mass is the product, the sum of the proton and the neutron. So in this case, by the time you find the atomic mass of this, it becomes 8 plus 8 equals 16. So atomic mass of oxygen is 16. In this case, the atomic mass of sodium is 11 plus 8, which is what? 23. Atomic mass of sulfur, 16 plus 16, which is what? 32. So the atomic mass is the sum of the proton and the neutron, as you can see in this example. and it is donated. If you want to represent an element, say an element Y or Z, let's say element X, for instance, will be represented in this case. This is the atomic number and atomic mass. So the subscript Z is the atomic number, while the superscript A is the atomic mass. One thing you should note, that atomic number is always smaller than the atomic mass. In fact, atomic mass is twice the atomic number. So let's give examples. For instance, oxygen, e.g. oxygen. Oxygen can be represented as O16. So this is how to represent oxygen. So meaning the atomic mass of oxygen is 16, atomic number is 8. So we can represent the number of examples like that. Sodium 2 can be represented as 1123, and so on and so forth. So that is basically the difference between atomic number and atomic mass. Okay, just like they said here, 40, 20. The other example they are giving to us is calcium. Calcium can be represented, this is calcium as a symbol. Then we have 40, 20, meaning the atomic number is 20, while atomic mass is what? 40. Let's move on. Another subtopic we are looking at today is isotopy. Isotopy. Isotopy is a phenomenon where an element exhibits the same atomic number but different atomic mass. What do I mean? For instance, let's go back to our calcium. Calcium may have 20, just like we have, and 40. So we say 40 is the atomic mass and 20 is the atomic number. So we may have another calcium which has the same calcium. You can see the elements are the same thing, which has 20 but 41. You understand? This phenomenon or this situation is called isotopy. Isotopy. You can have other examples like chlorine. That's carbon 6, 12. Then we can have other example 6, 13, carbon 6, 14, and so on. Other example, sodium. We may have sodium 23, sodium 24, and so on and so on. You discover that these elements are actually the same in this example 1. This is calcium, calcium. They are the same, but they have the same atomic number but different mass number. The same way here, carbon has the same atomic number 6, but different atomic mass. And don't forget, we say atomic mass is the sum of what? The proton number and the what? The neutron number. That is P plus N. Why this is the number of P. And don't forget, P is usually equal to the number of electrons. Now, isotopy is the occurrence of atoms of elements, just like we said, having the same atomic number. Mind you, having the same atomic number. The atomic number is always below and the same, but different mass number. This is due to what? The differences in the number of neutrons. What actually causes isotope, or what actually results in these differences, is because they have different in their neutron number. It is the neutron number that makes the difference between this element and this element. They are actually the same element, but they are in various percentage abundance of neutron. The atoms that exhibit isotopies are called isotopes. So these are atoms: calcium, carbon, sodium. We call them isotopes of what? Carbon. This is isotope of carbon. So we have carbon 12, carbon 13, carbon 14. So these elements are called isotopes. So carbon can be represented in different isotopes: carbon 12, 13, and 14. So the same thing as oxygen, carbon, calcium, sodium, and so on and so forth. Isotopes of an element have slightly different physical properties, but exhibit the same chemical property. This is because the neutron contributes only to the mass of an atom and not its chemical behavior. Yes, People will ask you, why is it that isotopes of elements exhibit the same chemical property but different uh, physical property? Yes, it is the neutron number that adds to the what? To the weight, because the neutron number determines the mass of an element. So why the chemical properties are actually the same? Yes, let's move on. Examples of isotopes, just like we have said, we have moved this, we have done this. Chlorine, we have chlorine 35, chlorine 30, chlorine 35 and chlorine 37, carbon 12, carbon 13, carbon 14, and so on and so forth. Now, in calculating relative atomic mass, you must take into account the different isotopic masses of the same element and their percentage abundance in the element. What do we mean by this? What is relative atomic mass? Relative atomic mass simply means is the number of times an element is heavier than 1/12 or carbon 12 isotope. What do I mean by that? For instance, we have calcium. Calcium has a relative atomic mass of 40. It means it is 40 times heavier than the lightest element, which is hydrogen. Hydrogen is 1. So the relative atomic mass of hydrogen is 1. So meaning calcium is 40 times heavier than what? Hydrogen. But what if we have calcium in different isotopes? For instance, we say we have calcium 40, 20, 40, 40. Then we have another isotope, calcium 20, 41. So does it mean we are taking the relative atomic mass of calcium 40 as 40 or 40? Which one do we take? In this case, we find the average of the masses. That is how to determine the relative atomic mass of isotope. For us to determine the relative atomic mass of any element that is an isotope, we take the relative atomic mass of that substance. And taking the relative atomic mass of, we have to take into cognizance what we call percentage abundance. So meaning calcium 40 has certain percentage abundance in nature. Calcium 41 has certain abundance in nature. So when you take the sum of this average, you get the relative atomic mass. From this following example we are going to do, you get the relative molecular mass of an element is the sum of the relative atomic mass of all the atoms in one molecule of a substance. It is referred to as the formula mass. Now let's see how we can calculate the relative atomic mass of some isotope. Let's look at the following example. Yeah. Calculating relative atomic mass of isotope. For instance, if we have given this question, example 1, an element with relative atomic mass of 16, relative atomic mass of this element is 16.2, contains two isotopes. 16, the isotopes are 16, that is phosphorus, let's say P, 98, can also be written as this, 98. Then another isotope, relative abundance, the relative abundance of this is 90%. We say relative abundance. Abundance is 90%. Then we have another one, which is Z, P, 98. The relative abundance of this is 10%. So if you look at this element, we have 16, 98. This is Z, 98. So meaning what? They are isotope because they are the same element. We define an isotope, if you remember, isotope are the same element having the same atomic number but different mass number. The same atomic number but different mass number. All right, let's take some examples of how to determine the relative atomic mass of some isotopes. Example 1, An element with a relative atomic mass 16.2. This element has relative atomic mass to be 16.2, and it occurs in two isotopes. The first isotope is 16 P98 with the abundance of 90% in nature. Then another isotope of the same element has Z as the atomic mass with 98 atomic number with 10% abundance in air. Now, how do we determine the relative atomic mass of we take the average mass of this isotope. So in doing that, we say relative atomic mass, which is 16.2, equals average of this abundance gives you 16 times 90 plus Z times 10 all over 100. Solving this further, we have cross multiply. If you cross multiply, this 100 multiplied by this gives you 1620 equals, multiply 16 times 90, that gives you 1440 plus 10 times Z, that gives you 10Z. So 16, bring like terms together, 1620 minus 1440 gives you 10Z. So if you solve this, this will give you 180, which is equal to 10Z. Z, the subject of the formula, divide both sides by 10 will give you Z equals 10. No, Z gives you 18. So the value of Z here means 18. An element Z exists in two isotopes. We have 39Z18, then 40Z18 in the ratio of 3 to 2, respectively. What's the relative atomic mass of this element? In this example, we can always calculate the relative atomic mass, giving you their different ratio, like this. So we said the element is Z, occurring in two isotopes. We have isotope 3918, that is 1839. The first one, Z 1839, with the ratio of 3. Then the other one is 4018, 4018, with the ratio of 2. Now, how do we determine the relative atomic mass of this substance? It is very simple. We determine this by finding the average. We say relative atomic mass is finding the average of this element. So to find the average, mind you, this is 2. We say three over 5. That is when you add 2 and this, you want 2 plus 3. That is the ratio. Times 9039 plus 2 times 40. That is the mass over 5. In that case, 117 over 5 plus 80 over 5. 80 over 5. All right. Taking the average of 5, that is the LCM to be 5. That gives us 5 goes here 1. So 1 times that's 117 plus 80. So 117 plus 80, that gives us 197 over 5. So 197 divided by 5, 39.4. So relative atomic mass of this is 39.4. Arrangement of electron in an atom. How do we arrange electron in an atom? That means we call that electronic configuration. Electronic configuration is simply a sequence of arrangement of electrons in an atom. When we say electronic configuration, we are making use of only the atom, only the electron in this case, unlike when we're using the proton number. So the way in which the electrons are arranged outside and around the nucleus is called electronic configuration. For instance, we may have elements like sodium with 11 electrons. Then we have chlorine with 17 electrons. Mind you, we said the number of protons is usually equal to the number of electrons. So you can arrange this in shells. Take for instance, chlorine. Chlorine can be arranged in shell. For instance, we have the first shell called the K shell. We have the second shell called the L shell. Then we have the third shell. After KL, then we have the L, M, then N, like that, depending on the number of electrons. So the number of shells determine the number of electrons. But mind you, there are capacity for this shell. There are number of electrons each shell can carry. For instance, the first shell, K, can carry the maximum of 2 electrons. The second shell, L, has the capacity to carry not more than 8 electrons. The third shell cannot carry more than 18 electrons. So this arrangement of electrons in their shell is what we call electronic configuration. Electronic configuration of elements. Let's move on. Electronic configuration, that is, the electrons are arranged in orbit known as shell, and they revolve around the centrally placed nucleus in the shell. Like you can see, this is the nucleus at the center. This electron revolve around. There are 7 shells denoted by K, L, M, N, like we said. These are shells, and each shell has the capacity to carry. Can we move on? Has the capacity to carry certain amounts of electrons. The nearest shell to the nucleus is the K. This is the nucleus, and the one that follows is the L, and so on and so forth. It has the lowest energy and contains the smallest number of electrons, which is 2. It cannot hold more than 2 electrons. The formula for calculating the maximum number of electrons in the shell is given as 2n2. 2n power 2, where 2, this is power, mind you, this is power, where n is a whole number, a whole number, which determines the number of shell. So for K shell, let's move on. Okay. With the number of energy level of the shell. When n is equal to 2, for L shell, we have, where n equals to, whenever n equals 2, we have 2 times 2 power 2. 2 power 2 gives us 4. 4 times 2, that gives us 8. So it means the maximum number for L shell is what? 2, because we are looking at is 8, because we are looking at the second shell. For this first shell, which is 1, this gives us 2, 1 square, which gives you 2. So like that, if you look at the third shell, 2, 3 square, the third shell being L, this is L, K, L, M. This is the third shell. This gives you 2 times 9, which gives you what? 18. 18, as you can see. So this formula determines the maximum number of electrons a shell can carry, 2n power 2. Apart from the KLMF shell configuration, we have some suborbital or subshell that this shell can be, can represent. Some of these electrons can be arranged. We have what we call orbits or orbital of an atom. An orbital is a region where the probability of finding an electron is high. It is a region in space within which there is a maximum possibility of finding an electron in an atom. We have the following orbital called SPDF orbital in a shell. S orbitals are actually elements that end up in metals. That is, any element that are called orbital, they are called metals. Metals, p orbitals are non-metals. Non-metals. Of course, you know the difference between metals and non-metals. Then d orbitals, they are transitional, the first transitional element. Transitional element. YF are what? The lanthanide, and the actinide. So let's move on. A shell is an imaginary line in which an electron revolves. Each shell is divided into orbitals. These orbitals are called SPDF. Each orbital has a maximum number of electrons they can hold. Just like we said for K element has the certain number of electrons they can hold. The same way for SPDF. SPDF. S can hold maximum of 2 electrons. P can hold maximum of 6 electrons. D can hold maximum of 10 electrons. While F can hold maximum of 14 electrons. You know? Just like we said 2, 4, 10, and 6. Now, we can arrange electron in such a way that this shell can follow a trend. For instance, if we have this trend K, which is 1, L, which is 2, M, which is 3, then N, which is 2. So meaning for these are the first orbital. We have the suborbital for this. So meaning this is S. For this, we have 2S, 2P. Two S, 2P, yeah. For this, we have 3S, 3P, 3S, 3P, then 4S. Then for this, we have 4S, 4P, 4D. I want to show you the short form of remembering how to arrange this element in a modern configuration. So, like I repeat, this is the first shell, 1S. The second shell, which is the K, 2 shell, and these are the sub. Then M, this is the fourth. So you can arrange this way, following this trend. You can see the arrow is pointing backward. So in this case, we have the first shell being S, 1X. The second one, like this, you follow this trend, 2X. Followed by this, 2P. Then after 2P is 3S. Then after 3S is this, 3P. Then after 3P is 4S. And so on and so forth, following this trend, depending on the number of electrons present in that order. So let's give examples. Example 1, you may be asked to find the electronic configuration of sodium in SPDF configuration. You know, we said these are the trend of arranging this. Mind you, I told you that S contains minimum of 2 electrons, P contains minimum of 6 electrons, D contains minimum of 10, then F 14. So for sodium, which is 11, how do we arrange in SPDF configuration? Let's see. Following this trend, sodium is 11. So the first one is 1s. I told you 2. So 2 out of 11. The following one is 2s. That's 2 again. Then followed by what? 2p. So 2 plus this. 2 plus that's 4. 2p 6. That's 10. You are left with 1. The following one is 3s. 3s1. So this is how to arrange sodium in modern SPDF configuration. 1s2, 2s2, 2p6, and 3s1. So by the time you sum all the subscripts together, you discover it's 11. Hope we are okay. Look at the examples. Another example here. Let's give this. Let's see chlorine. Chlorine is 17. Another example is chlorine. So chlorine can be arranged in this fashion too. 1s, 2, 2s, 2, 2p6. You know, the next one is 3s. 3s maximum 2. Then after this 3, they will have 3p. Mind you, this is 17. 1, 2, that is 10. 4, 10, 12. 12 out of this, that is 5. That gives you 5. So by the time you add everything to give you this. All right, these are the modern SPDF configuration for sodium and chlorine. And the beauty of this new modern thing is it enables us to determine their valency. I think in the next class, we'll be looking at what we mean by valency. Valency simply means the combining power of an element. For this place, that you know that the valency of sodium is 1 because it's all N in the SP configuration, S configuration, which is 1. And if you look at the P configuration here, the P orbitals here is 5. So it tells you that it's a non-metal. You know, sodium ends with S, meaning it's a metal. And the valency is 1. But in the case of chlorine ends with what? P orbitals, meaning it's a non-metal. And if you look at this, the valency is 1, minus 1, because the maximum capacity that P can carry is 6, but we have 5. So it needs what? 1 more to make it up to 6. What will it do? You rather borrow. So when you borrow, it becomes negatively charged. So we have come to the end of this class today. If you have any question or comment, please go down to the comment section and drop your comment. We shall get back to you. And then please don't forget to like, share, and subscribe to this channel so that we can always get across to you when we post new videos. Thank you.